The next concept that we are going to study is the rank of a system of equations or rank of a matrix. It is an essential tool while solving a system of equations. There are different explanations for rank. Here to start with, let us define the rank in a very simple way. So, rank is defined as the number of non-zero rows in any echelon matrix equivalent to a given matrix A. Rank of any matrix A is the number of non-zero rows in any echelon matrix equivalent to A. So, to define this concept clearly, let us take two examples, two previous university questions. So, let us solve these two questions. So, let us take the first one. First question. Reduce to echelon form and hence find the rank of 1, 2, 3, 4, 2, 1, 4, 5, 1, 5, 5, 7, 8, 1, 14, 17. So let me write here the matrix 1, 2, 3, 4, then 2, 1, 4, 5, 1, 5, 5, 7, then 8, 1, 14, 17. So the given matrix. So let us try to convert this to echelon form. So to convert this to echelon form, let me keep the first row as it is. 1, 2, 3, 4 needs no change. The second row. Now see the remember the properties of echelon matrix. We have to make every element below the pivot element equal to 0. So the first pivot element is 1. The first non-zero entry of the first element is the first pivot element, and we have to make every element below the first pivot element equal to 0 by using suitable row transformation. So let me write the row transformation. R2 to be transformed as R2 minus 2R1 so that 2 becomes equal to 0. Then the third row should be transformed to R3 minus R1 because hence that 1 also will get to 0. Then R4 to be transformed as R4 minus 8R1. So let us see how these operations transform the given matrix. So let us consider the first transformation R2 minus 2R1. So 2 minus 2 will give you 0. Then 1 minus 2 times 2. 1 minus 2 into 2. So we have 1 minus 4 equal to minus 3. Then we have 4 minus 2 times 3. 4 minus 2 times 3. And hence we have 4 minus 6. It is minus 2. Then we have 5 minus 2 times 4. So 5 minus 8. It is equal to minus 3. Now consider the third transformation. Next transformation R3 minus R1. So simply you have to subtract the third row and the second row. So 1 minus 1 it is 0. 5 minus 2 it is 3. Then 5 minus 3 it is 2. 7 minus 4 it is 3. So that is how the third row is transformed. R3 minus R1. This operation is applied to every element of the third row. Now the fourth row transformation is R4 minus 8 R1. So 8 minus 8 it is 0. 1 minus 2 into 8. So 1 minus 16 it is minus 15. Then we have 14 minus 3 into 8. 14 minus 24 it is minus 10. Then we have last element 17 minus 8 into 4. 17 minus 32 it is minus 15. So minus 15, 10 minus 15. So we have all the transformations. So we have this particular matrix. So hence we have transformed every element beneath the first pivot element to zeros. So up to the second row everything is perfect because the first non-zero entry of the second row is minus 3. Before minus 3 we have at least one 0 and that number of zeros before the first pivotal element of the second row is greater than the corresponding number in the previous row. So up to the second row, everything is fine. Now let us transform this again so that it is converted to echelon form. So we don't have to do anything with the first row. 1, 2, 3, 4 has no change. The second row also needs no change because 0 minus 3 minus 2 minus 3 is perfectly fine. Now we need to change the third row and the fourth row. So how to change the third row and fourth row? That is, with respect to the property of echelon matrix, we have to convert every element below the pivot element to zeros. So we have to make this 3 0 and we have to make this minus 15 also to 0. So the transformation is this 3 has to be converted with respect to this 3. Please note that this is the current row, or this is a row that is modified in the last stage. So this is the current row and we are doing every transformation with respect to this R2. Don't do your transformation with respect to R1. The transformations are to be done with respect to the current row or the row that is modified latest. So this is the current row and we have to modify every other row with respect to the row in which the pivot element that we are considering appears. Okay, so now we are considering the pivot element minus 3. It appears in R2 and therefore every transformation must be done with respect to R2. So let me write the transformation R3 to be transformed as R3 plus R2. R3 plus R2. So let us see how the transformation comes. 0, 3 minus 3 it is 0, then 2 minus 2, then 3 minus 3 it is 0. So that is the transformation for the third row. So that makes the entire third row a 0 row. And the transformation for the fourth row is R4 minus 5 times R2. Again the transformation is with respect to the second row because we are considering the pivot element minus 3 in the second row, or second row is our current row. So the second row transformations are done with respect to the second row. So the first element has no change. Second element minus 15 minus 5 into R2 minus 3. It is minus 15 minus 5 into minus 3, and so we have minus 15 plus 15 equal to 0. Next element is minus 10 minus 5 into minus 2, and hence we have minus 10 plus 10 equal to 0. Then last element is minus 15 minus 5 into minus 3, so minus 15 plus 15 it is equal to 0. And hence you can see that the given matrix is converted to this very simple matrix in which we have two rows full of zeros. So let us write the final answer. Rank is equal to number of non-zero rows in the final echelon matrix, and that is equal to 2. And hence the answer to the first question is 2. Hope it is clear to you. And see that in this final matrix, which is an echelon matrix, all the non-zero rows are above the 0 rows. Below every pivot element we have all zeros. So this is an example. This is an echelon matrix. We count the number of non-zero rows and hence the rank is equal to 2. So that's the answer to the first question. Now let me take the second question. If the matrix 1 minus 2 3 1, if the matrix 1 minus 2 3 1, 2 1 minus 1 minus 2 1 minus 1 2, 6 minus 2 AB is of rank 2. Find the values of A and B. So let me write down that matrix here. 1 minus 2 3 1 2 1 minus 1 2, then 6 minus 2 A B. So let us convert this to echelon form before getting the final answer. If you have to get the rank, you need to find the corresponding echelon form. So let us convert this to echelon form. To convert this to echelon form, we don't have to do anything with the first row. So 1 minus 2 3 1 remains as it is. Now the second row needs a change. We have to make this element 0 with respect to the first pivot entry. So the transformation is R2 minus 2 R1. R2 to be transformed in this way, R2 to be transformed as R2 minus 2R1, and therefore every element of the second row has the same change, 1 minus 2 times the corresponding entry in the first row, 1 minus 2 times minus 2, so it is plus 5. Then the second element is minus 1 minus 2 times the corresponding entry in the first row, so 1 minus 6, it is minus 1 minus 6, it is minus 7. 5 minus 7, the second entry is minus 7. Then we have 2 minus 2 into 1, it is 2 minus 2, 0. Now consider the third row. We have to make this 6 equal to 0 with reference to this 1. So the third row is to be transformed as R3 minus 6 R1, and therefore every element of the third row has that change, 6 minus 6. Then we have minus 2 minus 6 into minus 2. So minus 2 plus 12, it is plus 10. Then we have the next element as A minus 6 times R1. So A minus 18 as the next element. And the last element is B minus 6 times 1. So B minus 6 is the last element. So we complete that matrix. So we have made every element below the first pivot equal to zeros. Now again we have to transform it so as to get to an echelon form. So again in the next transformation, the first row needs no change, 1 minus 2, 3, 1 needs no change. The second row also needs no change because up to the second row everything is fine because before the first non-zero entry of the second row we have 1 0 which is greater than the corresponding number in the previous row. So we are following a step-like pattern. So no change is required for the second row. Now we are going to transform the third row. Now we are going to transform the third row so that the element below the pivot element, so this is a pivot element that we have now, element below the pivot element is to be converted to 0 with reference to this pivot element. So the transformation that we are going to write is R3 to be transformed as R3 minus 2R2. Remember, we are doing the transformation with respect to the pivot element or the row in which that pivot element appears. So second row is the current row for us. So this is the second row right now, and that is the current row, and we are doing the transformation with respect to that second row. So let us see how that change comes. 0, then we have 10 minus 10 equal to 0, and what is the next element? A minus 18 minus 2 times the corresponding element in the second row, so minus 14. Minus 7. So it is A minus 18 plus 14. So we have A minus 4. Then last element is B minus 6 minus 2 times corresponding element in the R2, and hence we have B minus 6 itself. Now what next? We are given a condition, we are given a clue in the question, we are given that the rank of the given matrix is 2. Now when the rank is equal to 2, so what does this 2 means? This 2 is the number of non-zero rows. So that means there are only 2 non-zero rows. That means the third row is a 0 row. So that gives A minus 4 is equal to 0 and B minus 6 is equal to 0. There are only 2 non-zero rows, means the third row is a 0 row, and therefore A minus 4 is equal to 0 and B minus 6 is also equal to 0, and therefore we conclude A is equal to 4 and B is equal to 6. So that's the conclusion. Given rank is equal to 2, we have obtained the rank values of A and B. A is equal to 4 and B is equal to 6. Thank you.